In this example, I need to solve the equation the square root of the quantity x minus 4 plus the square root of the quantity x plus 3 equals 1. What type of equation is this? Notice it has 1, 2 square roots. So this is a radical equation involving 2 square roots, and here are the steps for solving this type of equation. Step 1 says to isolate one of the square roots. It doesn't matter which one. So in my equation, I'm going to isolate the first square root, which means I'm just going to subtract the square root of x plus 3 from both sides of the equation. So I'm going to get the square root of x minus 4. These two square roots add up to 0, equals 1 minus the square root of x plus 3. So I've done step 1. Step 2 says to square both sides of the equation in order to remove the isolated radical. So I'm going to square the left-hand side. And then on the right-hand side, make sure you square the binomial. You can't square each term individually. So on the left-hand side, when I square the square root of x minus 4, I just get x minus 4 equals. On the right-hand side, when I'm squaring a binomial that contains radicals, I'm going to do it the long way, by multiplying 1 minus the square root of x plus 3 times 1 minus the square root of x plus 3. So I get x minus 4 equals, on the right-hand side, FOIL it out. 1 times 1 is 1. 1 times the negative square root of x plus 3 is negative the square root of x plus 3. Inner negative the square root of x plus 3 times 1 is negative the square root of x plus 3. And last, the negative square root of x plus 3 times negative square root of x plus 3 is positive the square root of x plus 3 all squared. So I get x minus 4 equals 1. These two middle terms here are like terms. I can add them together. Negative 1 and negative 1 is going to give me negative 2, the square root of x plus 3. And when you square the square root of x plus 3, you just get plus x plus 3. So on the right-hand side, I have like terms. So I have x minus 4 equals negative 2 times the square root of x plus 3 plus x, and then I have 1 plus 3 is 4. So I have completed step 2. Now, in step 3, it says if this equation still contains a radical, repeat steps 1 and 2. I still have a radical. So I'm going to have to isolate one of the radicals. I only have one left, so I'm going to isolate this radical. So I'm going to subtract x from both sides, and I'm going to subtract 4 from both sides. So these add up to 0, and I get x minus x is also 0. Negative 4 added to negative 4 is negative 8. Equals negative 2 times the square root of x plus 3. I need to go on to the next page, so I'm going to put it on pause for a second. This is the last step from the previous page. I'm isolating the square root of x plus 3, so I'm going to have to divide both sides by negative 2. Negative 8 divided by negative 2 is positive 4. Equals the two negative 2's reduce, and I get left with the square root of x plus 3. So I completed step 1 again. Now I need to square both sides again. So 4 squared equals the square root of x plus 3 all squared. 4 squared is 16. equals, what do I get when I square a square root? I just get x plus 3. So now it says if this equation still contains a radical, I've done that. I repeated steps 1 and 2. Now I need to simplify and solve the resulting equation. Well, this is a simple linear equation. All I have to do is subtract 3 from both sides. And I get 16 minus 3 is 13 equals x, and then 3 minus 3 is 0. So I have solved the resulting equation, but don't forget you must check for extraneous solutions, and that means plug the solution back in the original equation. So wherever you see an x in the original equation, you're going to put 13. So I'm going to get the square root of 13 minus 4 plus the square root of 13 plus 3. We have to check to see if it equals 1. So I get the square root of 13 minus 4 is 9, plus the square root of 13 plus 3 is 16. Does that equal 1? The square root of 9 is 3, plus the square root of 16 is 4. Does that equal 1? 3 plus 4 is 7. Does 7 equal 1? No. Therefore, x equals 13 is an extraneous solution. It was the only solution we obtained, so the answer to this problem is there is no solution.